Dear viewers, today I am gonna show the two-stage, three-phase grid-connected solar PV system. So in the part we have seen the two-stage conversion. Okay, so advantage of the our kit is if you want to working individually the boost converter, then it is work. Then individually you can work with the grid inverter, then it's work. Okay, so let's say the remaining part will show the function of boost converter individually and the grid inverter individually. Okay, so let's in this part we will see this boost converter function. Okay, so let's see in the boost converter we have working with two different mode. Okay, first the with this kit and this controller we have working it's working with simple boost converter. So at here you can connect this. So let's first see the connection. At the input side you can connect the DC, okay, by using this rectifier. Okay, and you can connect the input filter, and also you can connect the VPV sensor. Okay, means input voltage sensor. Then you can connect the IPV, then short link to connect the boost converter, and also connect the output capacitor, and here you can connect the load. So as per this diagram you can connect this boost converter with open loop or closed loop boost converter in the function. Okay, then you can connect this kit with the boost converter using the PV. Okay, so it will work in the CVT mode and the MPPT mode. Okay, so here for this boost converter working with MPPT algorithm in CVT and MPPT, then how you can connect it, let's see. Okay, so you can connect this PV to plus PV and minus PV here, and do not connect this input capacitor because we have connected the PV at the input side, and directly you can connect the plus PV to plus voltage sensor, and minus PV to minus voltage sensor. Okay, and we have connect the internally this current PV current sensor, and you can short by using the short links to connect the boost converter. And the output side now you can connect this capacitor because this is the only the boost converter with PV, no? So you can connect this capacitor by using the short links, and output of this boost converter you can connect the load. So let's check with the connections. So here you can see this capacitor is not connected here. We have connected the directly PV to this input side. Okay, and this short link is connected the VPV plus minus. Then here we don't connect this connectors because internally the current sensor is connected. Then here you can see the short links, and we have connected the boost converter, and also connect the at the load side we can connect the capacitor with the system, and here we can connect this load. Okay, then this controller is dedicated to this boost converter. So at the timer 8 PC 6 pin is getting the gate pulses, and here we can connect this VPV, IPV and VDC sensor input, and here you can see these numbers of VPV, IPV, and also you can see the boost converter ADC values and its controller pin. Okay, and function of this controller is switch function is like here. For boost converter PD7 is the system on off button. Once you can turn on and turn off this by using this button, you can turn on and turn off the system. Okay, at that time this LED will be indicating if system is off, LED is off, if system is on, LED is on. Okay, and by pressing this PD6 button you can change the mode. Once this so this is the switch. Okay, once you can press this switch, it is LED will on, then it is working in the MPPT mode. If LED is off, then it will work in the CVT mode. So in the CVT mode you can connect this jumper wire. Okay, so this is the PA0 button. Okay, so here you can see we have written here the vref is connected, vdc reference you can vary from the port, external port. So we have connect the external port at PA0 button. So here you can see we have connected the external port with this connect jumper wire. So PA0 is connected internally with external port. Okay, so by varying this port value you can adjust this vref value. Okay, so likewise this we can first see this CVT mode, boost converter working in the CVT mode, then we can toggle with the MPPT mode. So this is the 1 kilowatt system. So let's see the parameter of this PV. Okay, so at this time we have connect the solar emulator. So see the parameter of this solar emulator. Okay, so this is the parameter. Okay, so now we have working with turn on system. Okay, now let's say we have working this boost converter in the first CVT mode. So first of all we can turn on the PV emulator. Now turn on it. So once we can turn on this, here we can get the voltage. Okay, and here you can connect the load to up to the 70 ohm only. Okay, and you can see this point. Okay, now turn on the system with CVT mode. So do not press this PD6 button. Once in the CVT mode you can directly turn on the system by pressing PD7 button. Okay, so let's see. It is try to track at the reference voltage. Okay, okay, so it is settled at reference voltage. So you can see it is efficiency is 99%. Okay, now let's see the we have set the reference voltage with using this port to 150 volt. So here we can set this reference and actually is exactly match 150 volt, and it is working with 1 kilowatt system. Okay, 6.5 ampere is there, and this is the duty, 40% duty is there. Okay, now you can see the PV input output, and here you can see the PV output here, and this is the boost converter output, and this is the load. Okay, now we will vary this value, and you can see it is try to track. Okay, now you can increase it. Okay, same thing we will see on the graph of the PV. Okay, so let's settle first to 150. Okay, then we will see on the graph. Okay, so let's see, we will vary the values of vref and see how this graph will change. Okay, value will change and the graph will track like this. Okay, so in the experiment we have given the table VPV IPV. So in the CVT mode you can note down the different V and I values, and you can draw the graph, PV graph and VI graph. Okay, so likewise this you can perform this experiment in the CVT mode. Now, and also you can see if in the work turn on system you can toggle this PV into CVT into the MPPT, it will not work. Okay, because we have given the protection. So you can turn off it. Okay, then and then you can toggle with in the MPPT mode. Okay, so in the CVT mode you can get the 34% duty. So same duty will get into the MPPT mode. Okay, so let's, by pressing this button we can toggle it into the MPPT mode and then turn on the system. Okay, so let's see. Now it is try to track at maximum power. So you can see the maximum power point is tracked. by using P and O method. And here you can see the efficiency is 99.9%, and we can see the voltage, output voltage, and the duty, same duty you can get it. Okay, and it is, the power is 1 kilowatt, and this is the output voltage. So likewise this we can working this boost converter individually in the two stage converter, and you can perform the experiment in the CVT and MPPT mode. Thank you.